Okay, so we got a problem here with the race car. We're going to try to find its final velocity. The race car starts out here, ends up down here. 1,320 feet is actually a quarter of a mile, so that works out just great. What we want to do is trying to find the final velocity. So between 0 and 60 feet, the car spins its tires. So it's losing, it spins its tires, smokes its tires basically for the first 60 feet. So it doesn't get total traction. And that mu from 0 to 60 feet is 0.6. And then from the rest of the track, it's 0.85. So our resistance here is a little different from our resistance as it goes down. Once it gets traction, it gets a different resistance. Okay, so one thing we have to understand that 60% of the car's weight is on the rear tires. Your rear tires never have the total weight of the car unless it's being towed. But this car isn't being towed and it's not doing a wheelie, so it's perfectly fine. So the best way probably to understand this and quickly do it is going to understand that our kinetic energy final minus the kinetic energy, whoops, I don't know what's wrong with my marker here. Let's try this again. My kinetic energy final minus my kinetic energy initial is going to be equal to the total work done. All right, and work is defined as force times distance, basically. All right, so I think the first thing we can do is find the force. So find the force between 0 and 60. Let's see if we can find how much force and what's going on, and we'll multiply it times 60. So the force in this case is going to be definitely, force is going to be equal to mu times your Newton force. I mean, your normal force. So your normal force in this case is the same thing as weight. There's no angles going on, so your normal force is the same thing as weight. So your force is going to be equal to mu, which is 0.6 times the weight. Now be careful with the weight because 60% of the car's weight is on the back tire. So that's 0.6 times mg. All right, so that's the weight. This is the weight and this is mu. So we can put this now down into here. So we have this equals 0.6 times 0.6 times mg. And now we got to multiply this by the distance, which is 60 feet. Okay, perfect. All right, so my kinetic energy initial, the car starts at rest, so we know this is 0. We don't have to worry about that. So this would be 1/2 mv final squared. So the velocity is going to be this velocity as it gets to the 60 feet. All right, so you're multiplying it by this distance. So this velocity is going to be at the 60-foot mark. All right, so look at the masses cancel. Isn't that nice? So basically we're going to have velocity final is going to be equal to 2 times 0.6 squared times 32.2 feet per second squared times 60 feet, right, which is going to make that feet squared second squared, and then we're going to take the square root of this whole thing, and I came up with velocity final is equal to 48.1515 feet per second. So we know now that this is the velocity that the car reaches after it's spinning its tires for 60 feet at this particular friction, at this particular force, at this particular distance. This is going to be the velocity of the car at this point right here. All right, so let's try to see if we can find the final velocity, which is down here. So we're going to play basically the same game, the same little trick. You just have to be careful when we do this problem because we have some things that are just a little bit different. In fact, I'm just going to leave that velocity up there in the top there. My velocity at the final right here is 48.15. So let's see how we can solve this for the velocity final. So again, kinetic energy. I think I need a new marker. Kinetic energy. Kinetic energy final. Kinetic energy final minus kinetic energy initial is going to be equal to the total work done. All right. Again, we're going to play the same game. Work is force times distance. And then our force here, in this case now, the force is going to be equal to mu, which is 0.85 times our normal force. But don't forget, 60% of the car's weight is on the rear tires. So we're going to have to multiply that point 0.6 times mg. So here's the weight. So our mu times our normal force is going to be our force that goes over here and work. And don't forget, we got to multiply it by the distance. Now, let's just work it out. So kinetic final. So I'm going to have 1/2 mv squared, my final, minus 1/2 mv initial squared, right, is going to be equal to my force, which is 0.85 times 0.6 times mg times the distance. Okay, so now the distance isn't 1320, it's 1320 minus 60, which comes to 1260. So now my distance is 1260 feet. Okay, this is really important. This is easy to forget, to realize that you're not talking about the total distance here, you're talking about that minus 60. So you're subtracting out 60 feet from there. Okay, so what's my velocity final? This is what I'm looking for. My velocity initial is going to be right here. And oh, look, once again, all the masses cancel, which is just fantastic, right? And we're going to multiply this by 2. So we're going to have my velocity final squared minus this 48.15 feet per second. This is all squared. Is going to be equal to, once you multiply this out, this comes to 642.6 times g. Alrighty, good, fantastic. Now we're going to add this side to that side, and we're going to take the square root. So my velocity final is going to be equal to, let's see, 642.6 times 32.2 feet per second squared, plus 48.15 feet per second, and this whole thing is squared, and then we're going to take the square root. I came up with the velocity final as being 209.05 feet per second. Alrighty, now let's put that in miles per hour. Probably the easiest way to do is to do a conversion on Google, and miles per hour comes to about, velocity final equals about 142.5 miles per hour. So there you go. That is the answer to our question. I think the easiest part to understand is to use your kinetic energy formulas. Is use your kinetic energy is going to be equal to all the work that's put in, including whatever work is done, the work with your mu's, the tire spinning. Here the tire gets traction, so you get a different mu, and just keeping all that straight, making sure you know what work is, where your force is, making sure you know the real distance that you're measuring in, because you measured from here to here, and then you added in this velocity at the end, so you had to add in this part at the end, so that this part right here is this part, and then this part is from there, so you have to add them together. It comes about 209.5 feet per second, about 142.5 miles per hour. Not a bad car. I mean, that's a pretty good car. 142 miles an hour and in 1,320 feet, not bad. All right, thank you. I hope that you will subscribe. Hope this helps.